Alright, so the next section that we're going to do is going to be talking about the theme of neutralization reactions, which have to do with titrations, which is a skill that we're going to work on in the lab. A neutralization reaction occurs between an acid and a base, okay, and they always produce a salt and water. So an acid and a base, when they react, always produce a salt and a water, okay? It's called neutralization because you have that salt and you have that water. But that salt, when dissolved in that water, may still have a pH value other than 7. So I think it's important to look at that. The pH of that salt, okay, is dependent on the strengths of the acid and the base. So if you take a strong acid and a strong base, those are what the symbols are, S for strong, A for acid, B for base, okay? If you take a strong acid and a strong base, just like in tug of war, they're going to create something that's got a neutral reaction, okay? If you look at the next one, we've got a weak acid, W meaning weak, and we've got a weak base. Again, if you have two weak things playing tug of war, you're going to end up straight in the middle again. So it's also going to be neutral. Okay, I'm just going to write N for neutral. However, if you take a strong acid and combine it with a weak base, so think about one side of the tug of war is pulling very strong toward acidic, right? And the other side is only a little bit basic. You're going to have your salt produced be slightly acidic, okay, because it's leaning more towards that acidic side. So it's going to be slightly acidic. Again, my sketchy. So think about it moving upon the continuum of your pH scale from 0 to 14. You're going to have a strong acid and a weak base. It's going to have a salt that's slightly acidic and water. Alright, now what do you think about the strong base and the weak acid? So you have a strong base and a weak acid. Strong base, weak acid, same thing, it's going to be slightly, give little quotes, basic. There you go, there's some cursive for you. Okay, it's going to be slightly basic. So a titration is the way that we look at our reaction in a quantitative way, not just qualitative, but quantitative. So we're measuring numbers. It's going to be that volumetric determination of the point at which a reaction has been neutralized. That sounds really crazy, but basically what it is we measure what's the concentration and what's the volume of the acid. What's the concentration? What's the volume of the base? Let's compare them. Okay, when we compare them, we're going to look at the moles of each, okay, because the moles are important, not necessarily the concentration by itself, but your moles. And what we know about what we know about neutralization is we've got our moles of acid at neutralization are going to be equal to your moles of base. Okay, so at neutralization, your moles of acid equals your moles of base. And that is such an important theme for our titration because we're going to do calculations that calculate what are our moles of acid. And then we're going to calculate our moles of base. And we're going to see if they're equal. So while we're talking about titrations, we have to know what that is. Okay, so basically what we've got right here, we've got our ring stand. So write that in. I want you guys to draw this picture, have it in your notebook. Do the best you can. We've got a ring stand that's holding up. We've got a burette clamp. It's a burette clamp, C-L-A-M-P. Alright, and then this thing right here, it looks a little bit like a test tube, but it's graduated. So it's not a graduated cylinder, and it's not a test tube. It's kind of like a combination. That's called a burette. A burette. And what it does is it dispenses liquids. So what you can do is you can measure a volume here, and then you can add a little bit, and then it goes to here. And then you can say, oh, well, Let me grab a different color. The difference between them, that is going to be what your volume is that you added. Okay, so that's how the burette works. Right here, this is the stopcock, which operates the flow of the burette, all right, of the volume of solution going into the Erlenmeyer flask. Typically, we're going to put our acid in here, and then we're going to have our base in our burette. So you'll see that in our next screen. So I want you to make sure that you have this full diagram labeled with all of the parts. All right, so this is a little bit more of a cartoony drawing. We've got our burette right here, and we are going to put in that burette a base of a known concentration. So for us in lab, we're going to use NaOH as our base of known concentration. And we are going to have in our Erlenmeyer flask an acid of unknown concentration. So we know the volume, okay, but we don't know the concentration of this acid. Know the volume. And for us, we're going to be using vinegar, okay, and we're going to be determining what percentage of vinegar do we have. Okay, so we're looking for the concentration of vinegar. We know the concentration of our base. Okay, when we open up the stopcock, this base will flow in. Okay, our base is actually going to be clear. Our acid is going to start out also clear. And what's going to happen is we're going to put a couple drops of phenolphthalein in there. Phenolphthalein. This one was a hard one. Phenolphthalein. All right, that's going to go into our acid as well. And what the phenolphthalein is going to do is as we add drops of our NaOH, we're going to be swirling this. So we're going to see this motion. We're going to see this swirling. Okay, and when we get close to that neutralization point, it's going to turn pink. Okay, so when it turns pink, we know that we've reached that neutralization point. It's called the end point, or it's called the equivalence point. All right, so we'll see that in our next bit. So here we've got a titration curve that discusses and shows us kind of what we're looking at. So if you look on the bottom, we've got our volume added. So what they use is they use a pH probe, and they measure the change in pH that occurs as you add base to your acid. So if you're adding it, you go, it's steadily just going, and then all of a sudden right here about 100 milliliters, your pH skyrockets, okay? And when that happens, you take this and this, you look about halfway down, that's going to be your equivalence point. That is the pH at which your solution has been neutralized. Okay, that is the pH that your solution has been neutralized. So for this one, it's a little bit under 9 is what this one looks like. Okay? So we're going to actually find this out using a calculation. We're going to do a separate problem, but I just wanted you guys to see what do these charts look like? What does that mean? And it's also important to note that a neutralization doesn't always occur at 7. All right? It doesn't always occur at a pH of 7. So this is an example where the volume of base added, okay, is about 100 milliliters, and it actually leaves it at a pH just a little under 9 for this neutralization. So I want you to take a gander, and I would like you to take a guess and tell me, do you think this is a combination of a strong acid and strong base, a weak acid and a weak base, a strong acid and a weak base, or a weak acid and a strong base? So what combination do you think it is that at the end it was a pH of about 9? So take a guess at that and write it in your notes. It will be something that I'm looking for, so make sure you write it down. All right, last step is to know how can we use this titration stuff and neutralization stuff to do some calculations, to get some actual information and get some data. Remember, we talked about the key theme being that your moles of acids and your moles of base are going to be the same at neutralization. Okay? So at neutralization, you're going to have your moles of acid are going to equal your moles of base. And that's called equivalence point. So that's the equivalence point. You're going to have your moles of acid equal your moles of base. Make sure you know this vocab word. It's super important. right? And so what we use as our formula for titrations is going to be similar to something we've seen before, okay? It's similar to dilutions, because in dilutions, our moles, right, were the same in two different solutions. It was just change the concentration of the solution and the volume of the solution. Same thing here. Okay, so we're going to use moles of acid times volume, sorry, not moles, molarity of your acid times your volume of your acid is going to be equal to the molarity of your base times the volume of your base. Okay, so our example, if it takes 25 mils of 0.05 molar HCl, so we know that's our acid because it's got that H, to neutralize 345 milliliters of NaOH solution, so that's our base. Okay, what is the concentration of the NaOH solution? So we're looking for the molarity of that base. Okay, so I'm going to set this up. I'm going to say 0.05 molar of HCl is going to go over here, and I'm going to multiply it by my volume, which I can't use milliliters. I'm going to swap over. I'm going to say 0.025. Make sure you want to move your decimal point over 3 places to get that, so 0.025 liters. And that's going to be equal to my molarity of my NaOH, which I don't know. That's what I'm looking for. So we'll leave it there as MB, times the volume of the base. And I know that. I know that I'm starting out with 345 milliliters, which I forgot to write in liters. So 0.345 liters. So all you have to do is you want to solve for your MB, which is your molarity of your base, and you should actually take a moment, pause the screen. Okay, 0.0036 molar is the concentration of the NaOH solution. Thanks for checking in, and that's all for this unit. Woohoo! Last video. Good work, guys.